So what's interesting about this, and I promised I'd do this, is that you've got in this scenario to kind of prove this better. I like the way AI set the really kind of helped make sense because this is really important. I really couldn't show that with a 2 by 2 matrix. No wonder I was chasing my tail, kind of. But I could justify it with the vectors. In this example, you've got a 2 by 3 matrix, right?
Yeah.
And then on the other matrix, and notice you are taking the dot product, the x, the y, the z, the z, and you add those all together, you get a force. And I have that definition out here, loosely speaking.
Oh,
So,
wait.
right.
I understand it. Can I explain it?
Yes,
So basically, yeah, 2 times 5 times 1 times 1, 3 times 3. Yeah, that all makes up 20. That equals the first box.
that's
If you
right.
were to get the second box, you multiply these three numbers again, but this time with 2, 4, and 7. Like 2 times 2 is 4, 1 times 4 is 4, 3 times 7 is 21, 21 plus 4 is 25, 25 plus 4 is 29. That gives you the second. That gives you 1, 1, 2, right?
Wait, which one did you do? 213 and 247, or 402 and 247?
No, I'm saying that 213 and 247 gives you 29.
Got it. Got. So let's explain the ith, right? You're taking the ith row, right, of A, right, to get the 20. Let's go back to 20. The ith row here is row 1, 2, 1, 3, right? Just loosely speaking. And then you're taking the jth column, kind of going with this, of B, which is going to be 5, 1, 3, right? So the jth column of B is 1. So this is we'd say this is row 1 for A, and this is row 1 for B. Now, that's going to give you entry 1 and 1, is what we're dealing with here. That's what it's saying. But let's repeat this, right? You just gave me 402 and wait. What did you do for the second one for 29? Right. So this is entry 2 and 2, right?
So what I did is a 2. Okay, hang on.
Then it would be 402 and 247, wouldn't it?
Yeah.
And guess what? That's because the row of 402 is the ith row here is 2, right? It's row
Right.
2. And the jth column of B is 2, right?
Right.
So then your entry is going to be, wait, hold on a minute. That would be 4 times 2 is 8, 0 times 4 is 0, 2 times 7 is 14.
Yeah, so that would equal 20. That would equal 22. That's going to equal 2.
Right, that's going to be entry 2, 2. That's right, column, row, and column. So that if we set this up, if we come up with an algorithm, respectfully, if we've got entry 1, 1, 2, 1, 3, 2, 1, wait, 2, 2, 2, 3, right? And then you've got 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 3. What's interesting is this is a 2 by 3 matrix, first off, and this is a 3 by 2 matrix. But we ended up with a 2 by 2 matrix, right? You should know that your answer is going to be a 2 by 2 by your ith row and jth column. That also is sufficient for the matrix. So we know that our answer is going to be a 2 by 2. And I'll go through the proof of the numbers naturally. But then, you know what I mean? So if you did this by that, like before, the ith row is 1, the jth column is 1, entry 1, 1, if you were to do those two. Pretty cool, right? And you did the other one earlier. Now, I think that what's interesting about this is that this will not work unless these two, I believe, and I'll check it, are equal. And I'll check with AI to see if that is true or not. But let's just why not investigate ourselves? What if we had a 2 by 2, like earlier before, we had 1, 2, 3, 4, right? And we had 2, 1. And I was like, does this work? Now, this one works because these match. And we know we're going to have the ith row and jth column. So the answer is going to be ith row, j column here, a 2 by 1. Make sense? We know we're going to have a 2 by 1 entry or entries. But these matched. But what happens? What's interesting is what happens, and notice how this goes so much quicker if we just use logic, right? That's what I love about this stuff. You don't even have to do the numbers to know that it works. You just do it a few times and you're golden. That's why I love matrices. It's a perfect way of understanding things. So just to make that clear, that is going to give me a 2 by 1 answer because this is the answer. This is, I think, needs to match.
So it's a 2 by 2 multiplied by a 2 by 1. Yeah.
But let's try another situation where we have a. There was one we did earlier, but it would not work. Right? Remember that? We had like a. Right. So I was correct on that assumption. So you can do B times A, you can't do A times B because these don't match.
Yeah.
Right? And so let's go over this. If we did the 5 and the 7, I'm sorry, I've gotten a little tired, and I did this, right? And we showed this earlier, didn't we?
Right.
Where is it? It doesn't exist. We need a 2 to be there. We need a second column. However, if you look at the other situation, B times A, does that work? It sure does, because you can just drop the 1 and the 5, 7, can't you? And then the 3 and the 6, 8. This is why it's so essential in matrix math that you are going in the right direction given any problem. Some of them just can't be solved in a certain way. But could you do it in the practical sense depending on the system? I mean, I've done it before where, your basis ended up being the other way around, right? And so the B and A did work, right? Well, there you go. So it's just the math that doesn't work really. You got to make sure you're doing the right sequence in the math. Does that make sense? So let's go with the review on AI plus, by the way, not just generic. So my AI knows me quite well. So in terms of what we do and the accuracy I require. So we're clear on the fact that I don't trust my AI. I do the work. So it's an extension of ourselves, isn't it, Padawan? So that's right, Z. So because
what people don't realize, what really aggravates me.
Tell me, share me.
About what people don't. People are so. Forgive my language, but people are so dumb.
Well, they say that in Japan a lot to each other, so I get more motivational than it should be considered a connotation.
The human beings, although people say, oh, it's a machine that is generated. First of all the machine content putting in the generation was put by human beings.
Right.
Okay.
So you just explained why, right?
Yeah.
So if a bunch of human beings were jumping off of a cliff, would you do it?
Running its mechanisms.
Right. AI made me do it. Get that Donnie Darko stuff out of here. It's outdated. So, highly outdated. So, I know people are going to hate me out there for that. But here's the deal. You look here and the dimensions match, right? But if we do it the other way around, it's not going to work. So we know if we do A dot B, A multiplied times B, it's going to work because the dimensions are the same. And we should expect a 2 by 4 matrix, right? Do we need to do the math? No, I did an easier example to show why that doesn't work. But I could show here, pretty straightforward.
So basically, the what do you call it?
Let's try in blue, right? And we don't have to do entry by entry because now we know how the entries go in there now, right? So we can use Mr. Smasher's method, right? Now we know why it works, right? So now let's try A and B. So then I take B's and I sweep the 2, 0, and 4. I kick it up and I sweep it down. So then I drop the 2, 0, and 4, drop or die, Cage. Oh my God. So let's go ahead and do the first one. Now, if this is row one, column one, my answer is going to be the same. It's going to be one and one. So pay attention. Instead of looking at every entry, I look at the row and column because it really gets it done quickly. That's the beauty of it. That's the beauty of my justifications. That I knew how to do the math, but I forgot every single little piece of the proof. But we filled in the gaps for that today. So let's go ahead and drop 204 to this whole thing. Um, Let me just wait. Let's see. Wait a minute. Column one swept through both rows. Right. So then that will be, that's going to be, the jth really kind of determines where that's going to be. That's what's really kind of cool about that. So let's drop it on through. You got 2, 1 minus 1, and then you add the next entry in line, right? So then you've got, hold up a minute. Yeah, 0, and then you've got 2 and 3. It's the way I like to do it. And then you've got, sorry, my mind is falling off. My bad. You got, it shouldn't be. So you've got 0 and 4 and 4. So 4 and 0, 4. We don't have to do it all the way through, but we know it works. This is how you know it works because all of the jth, all of the row here fit into every single column here, right? And that's why your answer would be, the row. And let's see. And let's see if there's 3 rows there. The reason it works is this is 3 by 3, but you'll have a 2 by 4 answer, which is interesting. But you are multiplying into the let me put it like a red arrow. You are multiplying into, right, the columns of A from the rows of B. That's what's interesting about this. So that's why I sweep it up into that. So then now you get the 2 by 4, but remember you're multiplying into this. So the columns absolutely must match the rows must absolutely, the rows of B sorry, must match the columns of A. Makes sense? There's just a lot you can get out of these to make it right. So again, the rows of B must match the columns of A. Now that is the column of B, but each entry is a row. So that's why I don't know how to explain that any clearer with all these numbers and tuples going on. But then if we do the math here, you've got 2 plus 0 plus 0, and then you've got -2 plus 0 plus 16, right? And so then my answer is going to be what? Well, that means that this is going to be in the first column as dominated by B, because notice that I multiplied it by both rows, right? So I got both of my entry sets out of the way. Instead of just getting one entry, I went through the second row as well. And that's the whole magic by how I do my math with that. So now you're going to get 2 and 14. So then one of the answers is 2 and 14. And then you just keep repeating the process, like the 1 minus 2 and 0, the 0, 3, 1, and the 5, 1, and -1, right? So we know we've got let's see, we've got the first column of the matrix done, and we got others to deal with. So I'll do one more. I'll just keep going. But we could do the 1 times the 1 minus 1. And I do parentheses for my matrices. Like I call them matrix parentheses. It's the same notation. It's just easier to write out and quicker when I got something like this.
Plus -2, matrix parentheses 2 and 3.
You just about had enough. I feel you.
All right, then plus
Mr. Smasher.
0, and then matrix parentheses 0 and 4.
Very good.
I was paying attention.
Now notice that this is going to be the second column. That's what we should expect that to go into, because this was like both row 1 and 2 second column. So that's why Mr. Smasher's method, that the column dominates the columns, like that's going to be your answers. And it also kind of tells you that yes, the columns have to match how to put this. Sorry. The rows of B, right, have to match the columns of A, the inner part, the 3 and 3, the black line there. Sorry. So the black line there. So I don't know why this is doing its thing.
Yeah, so it's going to be 1. 1 times 1 is 1. Okay, and you want to, it's going to be a negative 1 down there. Yeah, so 2 negative, yes, would be negative 4. 0 times 0 is 0, okay, negative 1, negative 6, and positive 4. So that means that 1 minus 4 is negative 3, negative 3 plus 0 is negative 3. So that negative 1 minus 6 is going to be negative 7, negative 7 plus 0 is negative, yeah. So negative 3 will dominate.
Negative 3 would have been that first row, right? That would have been the entries for the, and notice if that's the first row there, that entries in the second column of B, that is that entry. That's the beautiful thing about it. And notice that my method said that the second row, right, in the second columns of B, that would be the -7. So we've proven everything today. Now, I'm not going to do the rest of that matrix. It's ridiculous. You will get the rest of it when you do it, right? So I would encourage the viewer to just do that. I've kind of gone into strict strategic detail as to why these work the way that they do. But if you want, would you like to finish it off? Let's do it together, actually. Why don't we? Let's finish it. Let's not be lazy. Let's not be lazy, bro. So
yeah, we're the Chinese.
Let's do it again. Yeah. Age of Empires, I guess. That's funny. I don't know why I just did that.
We're definitely not communists, though. We're just Chinese.
Okay, I want you to pan out right now on planet Earth, and I want you to go all the way to Pluto. Does Pluto care whether or not you're a capitalist or a communist?
No.
Okay. Enough said. That's all I'm saying. Like, I mean, hey, it don't matter to me, man. Be what you want to be. You know, just, you know, the world does push back. Always will. Challenges make us grow. So we know it's 214 that. Let's do the rest. Let's do the 1, -1, and let's do the third. So that's 0 plus 3.
Plus 3,
3.
matrix 2, 3, and then 1 in matrix 0, 4. 1, then matrix 0, 4.
0 so, plus 6 plus 0.
Yeah.
Pretty fast.
Yeah.
And again, third column, row 1, row 2, right? So your entry is going to be like 1, 3, 2, 3. Right? Those are going to be your entries.
6 and 13.
Right. So it's going to give me equal to
so
6
wins.
And 13. So then up here in our solution, remember this is going to be the 1, 3 because you're still doing row 1, but you're doing column 3. You're doing row 2, but you're still doing column 3. You just really see how B dominates, right? How its rows that have now turned into columns dominate when I sweep it off its feet. Ooh. So you've got 6 and 13. And I'll label them. You got entry 1, 3. You got entry 2, 3. Now moving on to the next. If we do the next here, let me go ahead and.
So it's going to be 5 matrix parentheses 1, -1.
Sorry, let me erase this. Okay, you were saying 2 to 1?
5. Okay. We're at 5. Then matrix parentheses 1, -1. Then after that, 1 matrix parentheses 2, 3, and then -1 matrix parentheses 0 and 4. So that's going to be 5 plus 2 plus 0. So
and now, this was what? We had column 4, right? So that's it. That entry is going to be what?
Anakin, Chancellor Palpatine is evil! From my point of view, the Jedi are evil. Well, then you are lost!
This is the end for you, my master. Ninja, vanish!